Okay, so here's our original equation. Negative 3c minus 12 equals negative 5 plus c. What should I do first? Well, not exactly like the last problem, but similar to the last problem. I'm going to pick the thing I'm going to move based on the result I feel is going to be the neatest and easiest for me. And when I look at this, I say, well, I'm going to first move the c's to one side. I'm going to get the variables on one side. Okay. And I know this. If I add 3c to both sides to undo this, then I get c plus 3c is 4c. And I have a positive coefficient on the variable. And for me, that seems a little neater. It doesn't actually really matter. You can move anything first and anything next. The idea here, though, is if you're going to say undo this with a plus 12 to both sides to get rid of there, then now on this side you would just have that negative 3c, and you want to get the c's over here. So once you make a move, then it's logical what's going to happen after that. So what I've done, I've chosen to undo this negative 3c with a positive 3c. Okay, positive 3c on both sides. So we've got what was originally there, and then the plus 3c. What was originally there, and then the plus 3c at the end. And now when I combine like terms, I get this. These two cancel out to leave negative 12, and these two combine to be 4c. What I said earlier, which is that, once you choose the first thing to do, that's going to dictate what happens next. Because now that we've done that and we've gotten this simplified result, well, we've got all the c's on one side. So now if we're not making extra steps for ourselves, we're going to deal with this and do the inverse of that to make it disappear on this side. So we've just got the c's all by themselves. So it's the inverse of minus 5. It is plus 5. So both sides, I take what was originally there, negative 12 in this case, plus 5. Take what was originally there, negative 5 plus 4c, and I say plus 5. Those will cancel out, and these will combine. So they combine to be negative 7, and these, since they cancel out, leave you with 4c. Okay. Now what's happening to c? We want to get it down to a coefficient of 1. Right now the coefficient is 4. This is the coefficient, the number in front of the variable. That tells you how many of them there are. Okay, learn that word, know what it exactly refers to. So what do? We want to undo that times c with a times 4 with a divided by 4. So we take both sides and we divide them by 4. Okay, and then we simplify. Now 4c over 4 just becomes c. This negative 7 over 4, we could turn it into a mixed number, but we couldn't divide top and bottom by the same thing. So I'm going to leave that as is, as an improper fraction. Okay, so we've got negative 7 over 4 equals c. For the proof, we're going to write the original equation. Negative 3c minus 12 equals negative 5 plus c, and then rewrite it again, but wherever there was wherever there was a variable, we're going to put parentheses, and we're going to put in the value we found, negative 7/4. Notice what I did. Because I have a fraction for what c is equal to, when I put parentheses to replace c with what its value is, I leave 2 lines. I make it 2 lines high. Okay. I personally am using 2 lines for my fractions because I want it to be nice and clear what I'm writing. You're looking at this and you should hopefully be able to see what I wrote. That is because I am being clear and neat about it. And you want to be clear and neat about your work too, so that everyone can see what it is that you've written and what you're communicating. Okay, now, how do we simplify this? Well, we've got this negative 3 times this negative 7, or a positive 21, and that's all over 4. Remember, the numerator gets multiplied by the whole number, because that's kind of like an invisible over 1. That would make the numerator times the numerator, and then the denominator times 1, which stays the same. Okay, so we get then 21 over 4. What else did we have? Minus 12 right there equals negative 5. And I just said, instead of plus negative 7/4, that's just the same as minus 7/4. Okay? Now, how do I add or subtract when I deal with fractions? Well, I need a common denominator. What's the common denominator going to be? Well, these both have 4, so we're going to make it a 4 on the bottom. I'm going to rewrite everything so that it has 4 on the bottom. So I've taken this 21/4 and it stays the same. I've taken this 12 and said, what if that was, instead of a whole number 12, That was over 4. Okay, so I put a 4 on the bottom. And what is 4 times 12? 48. So these are equivalent amounts. Okay, same thing here. Negative 5, how do I turn that into a fraction with a 4 as a denominator? Well, if this was over 1, then I would multiply the bottom by 4, so I have to multiply the top by 4. Negative 5 times 4 is negative 20. Okay? Now we've got them all over 4. So I can say 21 minus 48 is going to be the numerator and over 4. Okay? Negative 20 minus 7 is going to be the numerator, and it'll be all over 4. So 21 minus 48 is negative 27. And I put that all over 4. And here, negative 20 minus another 7. I'm down 20. I go down another 7. Negative 27 over 4. I simplified these sides completely on their own without ever crossing over the equal sign. I didn't add the same amount to both sides or anything because I didn't need to. This is an numerical expression. This can be simplified all the way down to a single value. This is also a numerical expression once you substitute the value of c in, and I can just simplify it. So I don't need to add something to both sides or otherwise move things across the equal sign. Okay? And what do we result in? Well, I found this and I found this separately, and then I compared them, and they are the same. So I'm going to check that's proper proof.